In this video, we'll wrap up our investigation of competition between species and discuss the competitive exclusion principle. We'll use the equations from the previous video, but competition will always give us essentially the same picture. So, knowing the stability of fixed points doesn't give us the full picture. For example, if meaningful competition exists between the two species, then the fixed point where they both persist is unstable. But if that were all we knew, we might see trajectories like this. We need to bring in more insight than just the instability of this fixed point. So remember that each of these species has a carrying capacity. If there were no competition at all, there would still be maximum populations that these species can't get past. And in fact, this 32 and this 28 are the carrying capacities. Why? Well, because on this line, where there is only one species and no extra species competition, the population growth is logistic. The population will grow to the carrying capacity. If this weren't the carrying capacity, the population would reach 2,800 and keep growing. And it can't keep growing. This is a fixed point. Likewise on this axis. So we're trapped in a box. This species can't have more members than its carrying capacity, so we can't be to the right of this, and neither can this species, so we can't be above this. We can't have closed orbits because there aren't neutrally stable fixed points. If we're stuck in this box and can't go in circles, it's perhaps inevitable that our wanderings will eventually take us near one of these asymptotically stable fixed points and will be pulled in. But to actually see what happens, we use numerical software to complete the picture. This is a saddle. We come in along there and go out along there. And every trajectory leads to the extinction of one of the animal species. Depending on which side of this curve we start on. What we have stated has a name. The competitive exclusion principle. If two animals are competing meaningfully for the same limited resources, then one of the animals will be driven to extinction, at least in the lake or forest or locale that this competition is occurring in. The competitive exclusion principle was first stated by Georgy Gauss, a Soviet biologist, in 1932, based on laboratory observations. He was looking at cultures of yeast and paramecium species, both of which required the same resources. And he observed that even though the species didn't actively harm each other, one of them was always driven extinct. The competitive exclusion principle is often stated as follows: two species cannot inhabit the same biological niche. However, life is complicated, and it must be acknowledged that sometimes unexpected things happen. One such thing is the paradox of the plankton, first described in 1961. All plankton species compete for the same limited resources, such as iron. They should be driving each other to extinction, but in fact, they coexist. Trying to understand this is an ongoing effort. It's not really my field, but I know that as recently as this decade, papers have been published on the paradox of the plankton, trying to explain what's going on here.